Hey everyone, in this video we're going to be reviewing tabular division, which is how we've been dividing polynomials in your core algebra classes. So first I'm just going to kind of outline why we want to set it up this way, why the table helps us do our division accurately and keep our work neat, and then later on you'll have a chance to just see how it works and practice these two examples. Then after we've done our two examples, we'll summarize our thinking, and you'll go on and complete the practice problems on the back of your sheet for credit in your intervention class or for additional support in your core class. So first, take a second, make sure you have your name on your paper, your intervention period and teacher, and then your core period and teacher. And core period, so if you have me, Mr. Waite, or Miss Gilbert, maybe you would say period 6, Mr. Waite, if you had me. But otherwise, fill in your appropriate teacher. Okay. So first, it says write this following expression in standard form. And we notice here there is a division happening between two polynomials. Now, we've seen how to multiply polynomials before, but we're trying to divide it here. And I want to first make it clear what the connection is between division and multiplication. So in this problem, we could also write it as a multiplication problem, saying, well, some number some polynomial times x minus 2 gives us the polynomial x cubed minus 8. So if we wanted to find that missing piece, we would need to divide out this x minus 2. What we do to one side of the equation, we have to do to the other. So basically, we're looking for a missing piece in a multiplication problem when we're doing division. All right, so that's sort of the motivation for why this tabular method works, and we've talked about tabular method for multiplication already. So let's review our steps right now. So if you're in my class, we have 3 steps that we follow when we do this. Step 1, we fill in missing terms. So what we mean by that is in our polynomials, there may be missing terms that we expect to see. So in this example, on top, we have a cubed term, x to the third. Now, in a full polynomial, there should be an x squared term after that, an x term after that, and then a constant term at the end. Here, we just have an x cubed term and our constant term. So to make our table work out nicely, we want to fill in those missing terms. We're going to need to fill in an x squared term and an x term. So our step 1 is just going to be rewriting that the numerator and the denominator with any missing terms filled in. So what that would look like for this problem is x to the third, that's our highest power. We're missing an x squared term, so I'm going to fill in a 0 x squared term. We know there's not any x squareds there, but we want to have all the parts when we go to fill in our table. And then next, we're also missing an x term, so I'll fill in a 0x. And then we do actually have a constant term. We have negative 8 as our constant term. So I'm just rewriting this division problem with the blanks filled in. On the bottom, we have our highest power is x. Normally after x's, we expect a constant. Oh, and we actually have both of those parts here. We have an x term and we have a constant term, so we don't need to fill anything on the bottom. X minus 2. So that's step 1. Rewrite our expression to have any missing terms filled in on the top and bottom. Then step 2, we need to figure out the number of rows and columns. So rows, there's a formula for this, is going to be the degree of the denominator, aka the bottom of our fraction, plus 1. Degree of the denominator plus 1. And the columns in our box is going to be the degree of the numerator, aka the top, minus the degree of the bottom, denominator, plus 1. So these two formulas we covered in class, they'll make more sense once we start to see why as we fill the box in. But first, let's just plug these in. So for the rows, the degree of our denominator here is, let's look at our denominator. Over here in our fraction, there's the denominator. This is a degree 1 polynomial. There's 1 x on the bottom, so the highest exponent is degree 1. So the number of rows is going to be 1, the degree of the denominator, plus 1. That's just a total of 2. All right, that was pretty easy. We'll try it for the columns. Number of columns is going to be the degree of the numerator. So let's look at our numerator. Here it is. The degree is the highest exponent. So the highest exponent here is 3. So that's going to be 3. Then it says minus the degree of the denominator. Well, we already found the degree of the denominator to be 1. So 3 minus 1. And then also plus 1. Plus 1. So 3 minus 1 is 2 plus 1 is back up to 3. So we've covered the first two steps, which are fill in the missing terms, figure out how many rows and columns are in our box, and then now we just get to make our box over here. So I'm making a 2 by 3 box. Remember, rows go horizontally and columns go vertically. So rows are 2. Yep, here's our rows over here. 1, 2 of them, and then our columns, there's 3 of them. Now this is like we said at the beginning, this is a backward multiplication problem. We're trying to figure out our multiplication, but backward. So the rows, we know one of our multipliers in our original problem up here was x minus 2. And then we also know the total after we multiplied was the top of our expression here. So in this case, looking back over here, I'm going to highlight in orange. That top was the total from this multiplication problem we're trying to work backwards. So the first term would be x cubed, 0x squared, 0x, and negative 8. So we filled in the totals, we filled in one of our terms. Now we just have to work our multiplication problem backwards to figure out the other term, which will be our quotient. So here we go. Working backwards, it says from this first box, it should be a negative 8, so we're just going to fill a negative 8 in there. Now that we filled in a box, we can fill in our top column. And it's basically asking, well, what times negative 2? What times negative 2 would give us negative 8? Well, 4 times 2 is 8, and it needs to make a negative in the end, so I need a different sign. So I need positive, negative, make a negative, and then 4. So positive 4 there. Great. So we've said positive 4 and negative 2 multiply to make negative 8. Now we can fill up the rest of our column. 4 times x, 4x. Now we're kind of out of information here. So when we get to the top of a column, we need to look diagonally for the totals from the diagonal. 4x plus something, we don't know what that is yet, needs to get to 0x. So right now we have 4 x's, and we need something else to get us down to 0 x's. So we need to take away some x's, a minus, and then how many do we need to take away? We need to take away 4. When we started with positive 4, take away 4, that brings us down to 0. So this should be, the diagonals tell us that they should total to our totals down here. Now we're sort of back to where we started. We have a term in the box, we have a term on the side. We can use that to fill in our term on the top. Negative 2 times what would give us negative 4? Well, that's just going to be a 2x. Change the color. 2x. 2 times 2 times negative 2 is negative 4. Check. And then x times, yep, the x. Good. Now that we have our top piece, we can fill in the rest of the column. 2x times x is 2 times 1 is 2. X times x is x squared. Again, we've gotten all the information from that column. Now we need to look diagonally and get our totals that way. So we have 2x's already. We're combining with something to make 2x squareds. We're combining with something to make 0x squared. So we have 2 of them. To get to 0, we're going to have to take some away, so I'll make a minus. How many do we need to take away? We need to take away both of them to get down to 0. So 2 minus 2 gives us 0x squareds. Back to where we started, we have a term on the bottom. We can fill in our top piece up here. negative 2 times what would give us negative 2x squareds? Well, it would be like negative 2 times 1 would give us a negative 2, and then we need x squared to get our x squared. All right, last one to fill in. This should just work out. We know that this box should be x cubed, so let's make sure our table works out. X times 1x squared is 1 times 1 is 1, 1x cubed. X squared times x is x cubed. Perfect. So the table worked out. Our totals worked out in all the diagonals. And what we found is this missing piece up here highlighted in yellow. We found the missing term, which is the result of our division. So the final answer to this question would be just taking that top box, x squared plus 2x plus 4. So this process has a lot of steps, and it just takes some practice to get used to them. So let's start with one more example, kind of summarize our thoughts. Again, back to our steps. So our first step was to fill in any missing terms. I see in this problem we have a cubed. We should have after a cube a squared. After a squared we should have an x. After an x we should have a constant. And it looks like, yes, we have all of these terms on top, so we don't need to fill any on top. On bottom, our x is the highest. After an x we should have a constant. And sure enough, we have an x, yep, and we have our constant. So we're not missing anything. We don't need to fill in any terms. So for our step 1, there's no missing terms. So I'm just going to put our problem right down here. X cubed minus 2x squared minus 65x plus 18. This one's got a big number in it. X minus 9. Step 2, we need to figure out rows and columns. Step 2, I'm going to go a little quicker on this one. Number of rows, remember, was the degree of our denominator. So let's look at our denominator. I'm going to highlight the denominator in orange. The degree of that, or the highest power, is just 1. There's just one x there. X, so the degree of the denominator is 1 plus 1. So that's 2 rows we expect. And then for columns, I'm going to highlight our numerator. The degree of our numerator, or the highest power, is a 3. So 3 minus the degree of the denominator, which we already found is 1, plus 1. And I'm just looking back at these formulas from our notes to get these the formulas. So we should have a 2 by, again, 3 box. 2 by 3 box. Step 3, we make our box and fill it in. Again, 2 rows, 3 columns. Our boxes don't have to be perfect. The bottom term, the denominator, goes over here. So the orange denominator, the x minus 9, is going to be filled in these orange spaces over here, x minus 9. Our totals, or the numerator in yellow, are going to be filled in each of the diagonal total spaces. Kind of make little arrows for them. Totals need to go like that. The biggest total is x cubed. The next biggest is negative 2x squared, negative 65 x's, and then plus 18. And then on top, this will be where we fill in the other term or our final solution. All we have to do now is do this box backward. So if you'd like, take a second, pause this video, try and do this process backwards, fill in your box, and then as you turn it back on, you'll be able to check your answers as I walk through them. So pause the video, walk through this box on your own, and then if you get stuck or when you want to review, just hit play and check yourself. All right, so hopefully you've tried this on your own, but I'm going to go through pretty quickly. 18 has to go in that box because the total is from there. Now it's asking, we can fill in this top row, or the top of that column. Negative 9 times what would give us 18? Well, 9 times 2 gives us 18. I'm going to start with a 2, but it's a positive 18, so we need a negative 2 times a negative 9. Negative and negative make a positive. There we go. Now that we have the top, we can fill in. Negative 2 times x is negative 2x. looking at this diagonal, we filled up our column, so we need to get our information diagonally. We have negative 2x's, and we need a total of negative 65x's. So boy, we need a lot more negative x's. We need way more negative x's. So we need to get more negatives. 63 x's. Right? If I have 63 and minus 2, those would combine to negative 65. Great. So now we have a problem asking us, we can fill in this top piece. What times negative 9 would give us negative 63? Well, 9 times, let's check, 9 times 6 is 54. 9 times 7, I believe, is 63. You can always check in a calculator. 9 times 7 is 63. So it needs to be a positive, because positive and negative will make our negative, positive 7. And then we need an x up here to get that x down there. Positive 7x, sounds good. Now we can fill in the next term. 7x times x is 7x squared. We have 7x squareds, and we need to get down to negative 2x squareds. Well, I need to take away some because we have too many. We need to take away. If I took away 7, that would get us to 0. So I need to take away 2 more than 7. So I need to take away 9x squareds. 7 minus 9 gives us negative 2. Check. Now we fill in the rest of our terms. Negative 9 times what gives us negative 9x squared. 9 times 1 would give us negative 9. And then x squared. So it would be just 1x squared. Last one should work out. X squared times x is x to the third. Yep, sure enough, that's what we expected. So our total, our solution, is again that top term I highlighted in pink. 1x squared plus 7x minus 2. And you don't need to write the 1 in front of the x squared. You can just write x squared if you'd like. Whichever is fine. All right, so now we've walked through 2 examples. You've been taking notes on these. And again, if I'm talking too fast through this video, feel free to pause it, right? The idea of having the video is so that you can go through at your own pace, check as you go. Also ask your intervention teacher if you have any clarifying questions. Okay, so summary, basically, to do these division problems, we have our 3 steps. Step 1, fill missing terms. Step 2, find the number of rows and the number of columns in our box. And then step 3, make the box and fill in. And just remember that that top column, the tops of these columns is our solution in the end. Solution is on the top. Okay. So now that we've walked through this, hopefully you'll be able to use these notes to go on to the backside and walk through these 4 practice problems. They're pretty straightforward, following from the notes. Use those step-by-step methods. Once you're done, ask your intervention teacher to come up and check your answers. They'll have an answer key, and then that will be your classwork for this makeup. All right, see you next time.